This is another SciTech Report.
My original concept was, if you were to take bubble wrap and visualize bubble wrap rolled inside of a tube, or as a tube like that, and you look down it, you could see as these bubbles would expand or contract, they would pump a fluid down the tube. I've got a high school education, and I don't have a degree from college. I've always been a hands-on type of person and always just taught myself how to do things. The difference between this one and this one on the formulation. Well, personally, it's been very satisfying to actually to come up with an idea and have people believe in it, and to see the engineers respond to it.
800% increase.
That's been the most satisfactory thing. Is the engineers see it and they go, "Wow!" So.
Harry asked me to come out and render an opinion on the quality of the technology that he had seen. And with my mechanical engineering background, when I saw what Mark had done, it was immediately exciting to me. That's cast,
Yep.
and that's after it's been expanded in just water. I'd done 2 prior drug delivery system companies, delivered those from concept to exit successfully, sold the last one to Baxter. So I had enough information about the market to understand when I saw Mark's technology that it had tremendous potential in a number of markets. Behind a microneedle dispensing a dosage
whatever you want
form
to
of
do.
drug.
Yeah.
So you could have...
When Mark McWilliams and I met, and we started talking about the material and how it works and how I thought it worked, what our testing showed that it did, he found it unbelievable, because he had heard of materials that could do like electroactive polymers, but none of them can generate the force. And if they can generate force, it takes high voltage to drive them. And here we had a material that generates high force, extremely high force, but runs on very low energy, under 3 volts.
This polymer has 3 properties that make it very remarkable. And those properties are, it goes through a large change in size, stimulated electrically, and it produces a large force. In a mechanical engineering speak, that equals work, force times displacement. And what makes that remarkable is that no other polymer has ever existed that got both large displacements and large forces. And if you don't have both, you can't do meaningful work.
Mark is an MIT graduate, so it's, kind of interesting to see the reaction from him. And the next one was Bill Bloom, who was a California Institute of Technology graduate. And his same reaction from him was, "Oh my gosh."
I came out of Mini-Med, and the little Mini-Med infusers that are used by diabetics have tons of parts. They're $3,500 to make one of these things. And it's all sorts of things that you got to put together just right. And so you've got errors in assembly, errors in the parts, mechanical breakdowns, everything that goes into it, and the cost. And suddenly you're replacing it with a very simple piece of bubble gum.
This is a...
and all we have to do is properly tickle the bubble gum with electricity at the right frequency, the right voltage, and the thing expands and squeezes the drug out. And not only does it do it for a few minutes, but we can make this thing work for weeks. So I went, this is the way of the future. This is something that is a game changer. And so I shamelessly begged to get involved in the project.
So the first investors we landed was, once they saw what it actually did, they just went, wow. And
Who was that?
Harry George. He's a VC in Tucson, and he's actually on our board now, board of directors. And it was with Harry's help that we got into our investment round. We got into the Desert Angels in Tucson.
We want to see Medipacs be a huge success. It's good for the community. It'll help create jobs in the community, help create tax base in the community. But then, ultimately, if there's some sort of event where the original investors can cash back out, then it's only going to increase the pool of monies available to other companies and technologies that are trying to be the next Medipacs.
As we develop things, the pump will evolve into other generations. That all looks good. We're only working on the first product now for the first drug. It improves the safety of drug delivery. It literally standardizes and changes some things in the industry, so it'll have a significant impact into the industry once it's implemented and adapted.
And the future for you?
The future for me would be, I'd love to see this graduate. It's kind of my baby, you know, get it out there and get going. And once that happens, then I can start focusing on some of the other things that we can do with that.
Really good results here. And in doing
A technical person that's had my kind of career really only gets a chance once or twice, maybe in their whole career, to interface with someone like a Mark Bannister. Mark Bannister is almost like a national treasure. He is a very, very prolific, very creative inventor. He's not tied to some of the structure that us that are used to more engineering processes, more academic backgrounds have. As a technical person in my role, I feel that it's important to kind of protect him. And that is, we take the best part of those and we call out what might be almost a distraction, and we refine that so that it is in fact a valuable idea that is worthy of patent and worthy of commercialization.
So once we launch this product and kind of get this off the ground, then we can start looking at a lot of the other applications. But it has battery applications, it has photovoltaic applications, it has filtration applications, it has all kinds of stuff, fuel cell applications. I can go on and on and on, but by tweaking it here and there, we can tweak it to each industry.
This has been another SciTech Report. For more information, visit technewsarizona.com.